Hello and welcome back to the Code of Rocket. Today we will be exploring the depths of neural networks, understanding their architecture, training, optimization, and applications. So without further ado, let's get started. First, what are neural networks? Neural networks are a set of algorithms modeled after the human brain's structure and function. They are designed to recognize patterns and interpret sensory data through a kind of machine perception. So basically, neural networks are trying to copy the neuron in our brain. So our brain is made up of small cells called neurons. And what neural networks try to do is they try to replicate our neurons in our brain inside of computers through coding and mathematics that include linear algebra. I know these things sound very hard, but trust me, you will find it easy to understand in just a few minutes. Now, let's discuss the key components of a neural network. Neurons, first of all. It's the basic unit of a neural network that receives inputs and produces an output. Then we'll come on to the second one, which is weights. That is the parameters, the things that adjust the strength of the connection between the neurons. Think that you have a rope which can be adjusted to the size that you want. That is our weights. Then is the activation function that determines the output of a neuron based on its input. Pretty self-explanatory, so we won't discuss this. Now let's learn how neural networks are trained. The first concept you will need to know in training neural networks is something that we call backpropagation, which is a method used to adjust the weights of the neural network to minimize the error in predictions. So basically what backpropagation is basically saying, oh wait a minute, I want to minimize errors. I want it to be as factual, as correct as possible. So that's where backpropagation comes in. Then second, epochs, which is the number of times the entire data set is passed forward and backward through the neural network during training. So basically, epochs means, imagine your data set as a book. Epochs is the number of times that AI or the computer goes through that data set. That's called epoch. For example, 10 epochs, 12 epochs. It can be how much we want. Let's discuss the role of activation functions in neural networks. As we've already touched, activation functions play a crucial role in neural networks by introducing non-linearity, allowing the network to learn complex patterns and relationships. So you don't need to right now be familiar or know what is non-linearity as a beginner. So don't worry too much about it. Just know that it's a concept that allows the neural network to learn complex patterns and relationships. Then the help in determining the output of a neural network. Activation functions help in determining the output of neural network, influencing the model's ability to capture and represent data effectively. Now let's discuss about backpropagation in neural networks. As you already know, backpropagation is a key algorithm for training neural networks by adjusting the weights of the connection between the neurons. It involves calculating the gradient of the loss function with respect to the weights and updating them using something that we call gradient descent. So let me explain. Backpropagation involves calculating something that we call the gradient of the loss function. Loss function is the function that calculates how much error or how wrong or ML model is, or machine learning model is, our neural network, how bad it is. And it does that with respect to the weights, and it updates them using something that we call gradient descent. Now you may be thinking, what is gradient descent? No worries, I'm going to explain that in a minute. Gradient descent is an optimization algorithm used to minimize the loss function in neural networks. So gradient descent is a function, it's an algorithm that allows us to make the loss and minimize that loss to make a better prediction on the data that we have been training on. It works by iteratively moving in the direction of the steepest decrease in the loss function. So it works by iterating and moving in the direction of the steepest decrease in the loss function. You don't need to understand this for much for as a beginner, but just remember that this will be important in later times. The learning rate in gradient descent determines the size of the steps taken during the optimization. Now let's discuss the types of gradient descent. Number 1, batch gradient descent updates the model's parameters using the gradients of the entire dataset. It uses the gradients of the entire dataset to update the model parameter. That is what we call batch gradient descent. Then let's move on to stochastic gradient descent, which updates the model parameters using the gradients of the individual data point. So here is some individual data points to update the model parameter. Then is mini batch gradient descent, which updates the model parameters using gradients of very small batches of data. It uses very small batches of data and updates the gradients using that. Now let's discuss the types of neural networks. There are 4 types of neural networks. First of all, we have feed-forward neural networks, which consist of input, hidden, and output layers. So have I mentioned there is a layer? Okay, we have layers in neural networks. There are 3 types of layers. Layers are basically a group of neurons grouped together. So input, hidden, and output layers. Information in feed-forward neural networks flows in one direction from output to input to output. It's commonly used for simple classification tasks. It's used for simple classification tasks like is it a cat or dog, or is it a cow, or what animal, or what food is this. This is where we use feed-forward neural networks. Now let's move on to recurrent neural networks that have connections that form cycles, allowing them to retain memory. It is suitable for sequential data processing like time series forecasting. It is used in natural language processing tasks such as language translation. Natural language processing is basically, as it's self-explanatory, processing natural language in ways that is useful. It can include sentiment analysis, which is basically saying, okay, is this input neutral, which means it's neither positive nor negative. Is it positive or negative? And also we have language translation. That was recurrent neural networks. Now let's move on to convolutional neural networks, specialized for processing grid-like data such as images. It uses something that we call convolutional layers to extract features from input data. It's highly effective in image recognition tasks with large data sets. If you have large data set of images and you want to recognize which image it is, it's better to go with convolutional neural networks. Then we have the last and less known. Okay, now I'm going to talk about key numbers. First, feed-forward NNNs have 3 layers. Okay, so and what I'm going to discuss in key numbers are the layers that are in or the neural networks. Okay, first, neural networks. Feed-forward neural networks typically have three layers: input, hidden, and output. Then we have the recurrent neural networks, which can have varying numbers of hidden layers based on the complexity. So it has one or more. It depends. It has one or more hidden layers. It depends on the complexity of the task. Then we have convolutional neural networks often consist of multiple convolutional and pooling layers. Alright, let's discuss the application of neural networks in image recognition. Neural networks are widely used in image recognition tasks such as object detection, facial recognition, and image classification. They have achieved remarkable accuracy in identifying objects in images, surpassing human performance in some cases. Surpasses human performance now. That's how far neural networks have gone in some cases. Not in all, definitely not in all, but some. Now let's talk about some challenges in training deep neural networks, or neural networks as we usually call them, that I have called them through this entire video. Overfitting and generalization. Deep neural networks are very prone to overfitting, where basically the model performs well if on training data but very poorly on unseen data. So if you ask it something that how to train on, it will perform very well. It will give an accurate answer as long as the data set is accurate, but it works very poorly on unseen data. Achieving good generalization involves techniques like things that we call regularization, dropout, and data augmentation to prevent overfitting. We have to prevent it. We use these techniques. Now let's discuss some ethical things that we need to take in consideration while developing neural networks. Number one, we have to ensure transparency in the decision making process of neural networks. How do they make the decision? We need to make sure we transparently document that. We need to consider the impact of biased data on the outcomes of neural networks algorithms. So make sure that your data set doesn't have some biases in it that can impact a lot on the neural network. Implement mechanisms to protect user privacy and data security in neural network applications. Don't be like Google. Don't be like the big tech companies. Make sure to take your users' privacy and data security into consideration. Remember this throughout the development cycle. Now that we have touched on various things in neural networks, I would like to say my goodbyes to you until next time. But make sure to like, subscribe to the channel and share this video.